Hello, my name is Albert Espinosa, and I am an instructor in mechanical engineering at Universidad del Turabo in Puerto Rico. In this video, I'm going to discuss some of the work we have done here at Universidad del Turabo towards implementing hands-on learning in some of our mechanical engineering courses. One of the main reasons why we are moving more towards hands-on learning is mainly because students have shown a deep level of dissatisfaction with the faculty's emphasis on theory versus practice. They say that we give too much theory without many practical, real-life examples. And as a result of that, Universidad del Turabo is trying to move more towards hands-on, active learning type of in-class activities. And towards this effort, during spring of 2015 and the fall of 2016, our faculty was introduced to the Annual Discovery Board. This effort was led by Dr. Juan Carlos Morales, Dr. Jacob Setake, and Dr. Ken Connor. And as a result of this introduction to the Annual Discovery Board, currently several hands-on moving learning type of activities have been integrated into some of our ECE on some of our mechanical engineering courses at Universidad del Turabo. And I'm going to discuss my side of the effort, which is the mechanical engineering part. In mechanical engineering, we use the Analog Discovery Board to teach fundamental core topics in mechanical vibrations and control theory. All activities are completely run by the student in lab and only require components including in the analog parts kit, which is the component kit that you can buy alongside the Analog Discovery Board from Digilant. The instructor only oversees the lab activities and answers any questions that students might have during lab. But at the end of the activity, the student submits a short report that includes not only the methodology that was used in the lab, but also a short reflection on the lessons learned and questions about the connection between what they did in lab versus what they would expect to find in a real world setting. And with that in mind, I'm going to discuss the first activity, which we have included as part of our mechanical vibrations course. And this activity involves measuring the damping ratio using the logarithmic decrement method using the Analog Discovery Board. So the main idea behind this activity is that we want our students to get a deeper insight into how the spring coefficients and the damping coefficients, in this case the damping ratio, for any given mass spring damper system is obtained in practice. And we also want the students to be able to set up and gather vibration data using an accelerometer. And in this case, we use the accelerometer that is already included in the analog parts kit, which is the ADXL 327. And once the students are able to gather data from their accelerometer, then we want them to use this vibration data to determine the damping ratio using the logarithmic decrement method. So the post-processing in MATLAB consists of three main parts. In the first part, we simply extract the data from the created Excel file, which we created using the Analog Discovery Board, and we import that data into MATLAB. In the second step, then, what we do is we extract only the relevant data, which is our peak information or our peak data from that raw vibration response. And what we do with that data is that we simply use MATLAB's own peak detection functions to extract the peak locations and their amplitudes in order for us to be able to use the logarithmic decrement. And then in the final stage, and what we do is just use the equations that presented in a previous slide to determine what is the damping ratio of the system using only that peak data. So that's essentially our entire first activity. Like I said, is focused mainly on core fundamental topics. It's meant to be straightforward and easy for the students to implement on their own. But I think it has very many good lessons and good practical applications that they can take away from this activity. For the second activity, This is an activity that we use in our course in controls. And this is essentially an activity that I use to teach the students a little bit more about how to analyze a second-order system. So for this activity, we decided to analyze an electrical circuit, namely an RLC circuit, and we use this circuit to analyze its system response parameters, namely the peak time, rise time, settling time, and overshoot. And the idea behind this activity is to have the students refresh a little bit on their circuit building skills. And not only that, but to be able to compare measurements that they will make from this circuit with theoretical calculations that they do with the equations that they learn in class. And the idea behind this is to, show the students that the equations that we use in class do match up fairly close to what we would expect from a real physical system measured response. And that's the basis of this idea. So for this activity, we use both the wave generation capabilities and the oscilloscope functions of the analog discovery board. So the post-processing for this activity is rather straightforward. First, the student uses the nominal values of the RLC circuit to create a transfer function model using MATLAB. And then the idea is that with this transfer function model, they can compare the results in simulation versus the results obtained experimentally using the analog discovery board. And the results match up fairly close. So the idea is that the students then take these results. They know that now that the transfer function model that they learned in class does match up pretty closely to what they see in the experiments. And not only that, but they can use this results to determine the system parameters, in this case, the system response parameters, such as the rise time, peak time, settling time, and the overshoot. So in a nutshell, those are the activities that I have incorporated into some of my mechanical engineering courses using the analog discovery board. Overall, some of the lessons that I've learned from using the analog discovery board is that it's a very powerful yet simple to use platform for data acquisition and function generation. And this platform has a lot of online documentation that and tutorials that the students can use to further their learning on how to use this device. I find in my experience that the students find the idea of quickly performing data acquisition very empowering and very appealing. A lot of times the students ask for more activities using the analog discovery board to analyze different types of systems. Also being able to experimentally see how the theory learned in class applies to real physical systems helps students further solidify those fundamental concepts. And I find that the integration of the analog discovery with MATLAB is a very powerful tool for data analysis, as well as to be able to compare the experimental results with system models so that the students can see that what they learn in class actually has application to real world systems. That's an idea of what we're working here as far as hands-on learning at Universidad del Turabo. Thank you for watching.